Good morning. This is Stephen at QuantumDynamX, where the future is unevenly distributed. It's here more than you might think. So today we're working on an agentic operating system of the future in Rust. So this is an example of how agents have changed what's possible. They're an equalizer. I've never written a line of Rust code in my life. I didn't really even know it existed. Actually, I didn't even know you could make an OS. But my friend Jeff always has a knack of pointing me in a certain direction. And we'll talk more about that story later. But he pointed me in the direction of the OS hasn't changed in 20 years. What would it look like? And I immediately wanted to make a robot head. But we started with just trying to make an operating system. So you can see here we've got, I think it's a bare metal framework that we used. We've actually got services, we've got a drop-down memory, we've got a reset, power down, change, eject. So we've got some memory management there. We've got some view of our main menu here. We've got speed, windows. So we definitely have a booted system. The next step is to try to get Thomas in here. So Thomas is actually here. All systems nominal. All the agents from the Agent Alliance will be joining in our system. So the next step is to make some decisions about how do I add intelligence. We know the four things: the prompt, the model, the loop, and the context. So we're going to go with something that we learned fundamentally with all our agents is we need to have like a nice character prompt. We need to have a nice intelligent model to work with. We always like to have 4 tiers of memory that helps us learn and grow. And I started these as just markdown files, so they're pretty primitive, but they're just different aspects. Now we actually have database, session, application, so it's getting a little more complicated. And then the reflection loop is the one that really was the big key, because the reflection loop, even in my cursor, kind of goes through and looks at what we've talked about, writes lessons learned. We kind of came up with a format. That's the same reflection loop that we use with Wheeler-Watson. And that guy is one of the smartest physicists I've ever met. See if I can pull him up real quick. But that's where all this started on Thanksgiving with the Wheeler-Watson Institute. This is actually a knockoff of the project that's called Cosmos. And Cosmos has, let's get back to the app. So Cosmos has a world memory. So you have to be invited to one of these. So this is my empirical research on fiber bundles. And then inside of here, we have our world memory. So every time we read a paper, if we go to the document research, we want to do a literature research and find some more papers about, this is my citation manager. These are all the different research bundles, fiber bundle topology and semantic space. So we're trying to understand how to take markdown documents and put them into a semantic embedding, and then understand really what takes place. There's a lot of flaws inside of vectors. They do simple things. And here you can actually see the effect. You can see the markdown file. You can see the similarity. I'm not going to the full, but you can also start to explore. We put in 2 sentences. We could see how they're related. We put in 2 sentences that were, I went to the bank by the river to deposit a check. My cat pooped on the bed. And surprisingly, those scored semantically similar because of the structure of the sentences were the same. So there's some, and I know there's a lot of research, but that just shows that there's a lot of unknown limitations to semantic embeddings that people, when they throw everything in a vector space, they're not really aware of. So how do you explore those? Well, we made a visualization tool, which I've showed you in previous episodes. So to get back to where we are now, this was the first intelligent agent where we have continuous autonomous learning. This whole system has an orchestration, and we can run these agent researches on the topic that we have. We have autonomous running agents. This is all basically in, well, lovable, to be quite frankly, which is cute, and it's amazing that it works. It has a database, has some stuff. But now we're going to go step it up a notch. And we have our reflection loops that you can see from Dr. Wheeler. It's all the conversations I've had with Dr. Wheeler. And then he looks at the transcript and we kind of find out insights, actions, we kind of boil it down. So now we're going to make an agentic operating system from the ground up. So what is it going to do? So it's going to boot up, it's going to have Thomas. What are some activities that I want my operating system in the future to do? Well, the first thing I do every morning is my daily ambition, where I work with my agents and we kind of plan the day. So today we're going to add the daily ambition ritual to Thomas. And we're going to add Thomas in the orchestrator. Thomas is going to come in. We're going to do a prompt. It gives him a character. We're going to either do a local model or we're going to make a call to API. And of course we have our Qiskit hobby here. We probably won't use quantum that much, but that's how this all started, was trying to learn. So here is what we're doing, and I will keep you posted on the progress, but I can tell you it boots, and you can even type in there and you can do all kinds of stuff. But now Thomas needs a brain, and that's what we're going to give him. Thank you for listening. This has been Stephen Dulaney, Quantum Dynamics. Please like, subscribe, leave a comment.